talk about how do we propagate uncertainty while subtracting two physical quantities in this video. This is also most commonly asked question in paper 1B IB physics. Okay, so now let us suppose I have a physical quantity A which is as A plus minus delta A in this form. Okay, and I have another physical quantity B which is given in this form, b plus minus delta b. There will be numbers in place of a, delta a, b, delta b. I'm not taking any number right now. Okay, now let us suppose I want to find out c, and c depends on a and b by this relation, that c is equal to a minus b. Okay, now how do we do that? Now how do we find out c and the absolute uncertainty in c? Now to find out c is very simple. We are doing it since childhood. Okay, so c is nothing but a minus b. That means original value of a, which is a, minus original value of b, which is b. So c came out to be, I'll just have to subtract b from a. Cool. Now what about delta c? How do we find out delta c? So to find out the uncertainty in c, do you think we do this, delta a minus delta b? Hell no, girly. No, no, no. We don't do that here. This will give you a wrong answer. Okay, so now let us discuss a little bit about it. So, whenever we are subtracting two physical quantities, we don't subtract their absolute uncertainty. You know, subtracting the absolute uncertainty means you made a mistake in measurement. Let us suppose you were measuring a length of the rod A as A plus minus delta A, length of the rod B as b plus minus delta b. That means here you already are this much uncertain, and here also you are already delta b, this much uncertain. Now you want to find out like how long a is, then b. So basically you are doing a minus b, and if you're doing a minus b, and upon doing so you are doing delta a minus delta b, it's like subtracting your mistakes. You have already made that mistake here while measuring a, you have already made the mistake while measuring b. Now a minus b will come with the mistake of a plus the mistake of b. It can't get subtracted. Okay, so even in subtraction we add absolute uncertainty. So please remember, while subtracting two physical quantities, we add absolute uncertainty. The same thing we do in the addition as well. In addition and even in subtraction, we add absolute uncertainty directly. Okay, so here delta c will be nothing but delta a plus delta b, because absolute uncertainty in a is delta a and absolute uncertainty in b is given delta b. I hope I'm clear here. Okay, now let us understand it better taking an example. So let us say I have a physical quantity a as 16.0 plus minus 0.3. Okay, I have another physical quantity b as 18.0 plus minus 0.5. So let us suppose I want to find out c, which is b minus a. I want to find out c and I want to find out the absolute uncertainty in c. So in this case, what do I do? To find out c, I will simply do b minus a. Means original value of b minus original value of a. That means original value of b is 18 without its uncertainty basically, minus 16. So the value of c I get as 2. Right, now talking about the value of absolute uncertainty in c. So as we discussed, we have to add their absolute uncertainty. So delta c will become 0.3 plus 0.5, which gives me 0.8. Now here comes the main part, very important. So I got c as 2.0 and delta c as 0.8. Now how do I write it with a correct number of significant figure and matching the precision? So what is the first rule? The first rule is round your absolute uncertainty to one sig fig. So let us check. I have only one sig fig, only one significant figure already in absolute uncertainty. So I don't have to change that. Cool. So I can simply write plus minus 0.8. Now the second thing is I have to match the precision, right? So I will match the precision with the main value. So precision matching means I have to see the number of decimal places. So I have only one decimal place here, right? So my main value should also come with one decimal place. So my final answer will be 2.0 plus minus 0.8, and here you never lose marks in this. Thank you.